Hello everyone. We today discuss uh, physical chemistry. It is chemistry paper 1, semester 6, introduction to polymer chemistry, which is a special unit for 15 lectures, that means 25 to 20 marks. Polymers are very important now. Uh, there is a special branch after BSc, that is MSc in polymer chemistry. Means similar to organic chemistry, inorganic chemistry, physical chemistry, polymer chemistry is a special branch. And nowadays, that polymers are very that widely used in solar cell applications, also in mobile devices, that is mobile screens, computer screens. Many researches is going on to improve qualities of solar cells, polymer based solar cells, and in and already these polymer solar cells, that is a new application of that polymers. But before that, we already know that bone, that is body parts, uh, that are also polymers are so useful for that purpose of body parts. Then we discuss here, what are polymers? What is polymer? Polymer. Poly means many. Mer means molecules. Poly, that is many molecules. Many molecules, as if we consider that word polymer, meaning of that. Then it is defined as, polymer is defined as a high molecular weight compound formed by joining of large number of small molecules. That is, polymer actually is a very big molecule, large molecule, which is formed from joining of small molecules, many small molecules, joining of many small molecules. And that resultant large molecule is known as polymer. Similar to chain, that chain is made up from small units, repetition of that small units. Here molecule is also made up from repetition of small unit, that is small molecule, which is known as monomer. And total that chain, similar to chain, that chain like molecule is known as polymer. Then that process of formation of that polymer, that is long chain, by joining small units, small molecules known as monomers, they join to form polymer. That process is known as polymerization reaction. Polymerization reaction is nothing but process of formation of polymer molecule. Then that's here, suppose n number of, that n may be 300, 400, 500 in this range. That n number of ethylene molecules join together to form polyethylene as a polymer. That one is shown as dash CH2 dash CH2, as like that. And that total, how many units joined together? N number of. That means if here monomer is considered as ethylene and polymer form is polyethylene. Molecular weight of ethylene is already known, that is 2CHC means 24 and 4H, that is 24 plus 4 means 28 is the molecular weight of single monomer, that is ethylene. Then what is molecular weight of this polyethylene molecule, which is polymer, that n into 28, that is if there are 300 ethylene molecules joined in a chain, then 300 into 28. If 200 join together, 200 into 28, as like that. Therefore the size of molecule is decided or depends on this n, that is larger the number of n, more is the molecular weight, more is the size of that polymer molecule, and that n is therefore here known as degree of polymerization. Degree of polymerization, that is nothing but equal to number of monomer units which join together so as to form that polymer molecule. Then classification of polymers. There are different methods for classification of polymers, different type of polymers, and here for classification also based on different methods. First method is based on type of monomers, that is classification based on type of monomers. This is first classification method, that depends on monomer from which that polymer formed. Polymers are classified as homopolymers and copolymers. Homopolymers means that polymer chain is made up from only single type of monomers, joining of only single type of monomers, that is considered here A type of monomers, A repetition of A as a single type of monomer. Then copolymer, polymer formed from two or more than two type of monomers. Here general example AB, as like that, two type of monomers here shown, that is A and B. Then next classification is classification based on type of chain, type of polymer chain, type of polymer chain. Based on that, polymers classified as a linear chain polymers. In linear chain, polymer chains are straight chain polymers that are known as linear polymers. That may be homopolymer or that may be copolymer, but chains are linear. Then next is branched chain polymers. Second type is branched chain polymers, that monomer units join together to form branches like this. Branches are there, chains are nothing but not linear, there are branches, therefore branched chain polymers. Then cross-linked polymers, that monomer units join together to form three-dimensional network structure, then that type is known as cross-linked polymer. Here shown example, that is general structure for that cross-linked polymer. Then next method for classification is based on arrangement of monomers in a polymer chain. That classification based on arrangement of monomers. Based on arrangement of monomers, that polymers are classified as regular copolymer and regular copolymer. In regular copolymer, monomer units are arranged regularly. Then random copolymers. In random copolymers, monomer units randomly arranged, no any sequence. Then block copolymers. In block copolymers, similar monomer units joined in relatively long sequences that are known as blocks. That is here A, then B. Such four blocks, four monomer unit block. Single block is of four monomers. Such blocks are there, and that polymer chain is formed from such monomer blocks. Then that one is known as block copolymer. These are classification of polymers based on that arrangement of monomers. Last type is graft copolymer. Here backbone chain is formed from single monomer and branches are formed from another type of monomer, then that are known as graft copolymers. This one is similar to grafting, that is backbone is same and branches are different, therefore here that are graft copolymers. Then classification of polymers based on origin. Based on origin, polymers are classified as natural polymers, semi-synthetic and synthetic. Naturals, that are isolated from nature. For example, rubber, wool, silk, cellulose, protein. That rubber is from rubber plant, wool is from that ships, that silk we know, and cellulose is nothing but cotton. Then proteins, that all have natural sources. Then semi-synthetic, these are polymers that are formed from some chemical modifications in natural polymers. That is, chemically modified natural polymers are semi-synthetic, not 100% synthetic, not 100% natural. Therefore, that are semi-synthetic. Then synthetic polymers, that 100% synthesized in laboratories, that are nothing but no any natural source, therefore that are completely 100% synthetic. For example, nylon, polyethylene, these are such type of polymers. Then classification, next type is classification based on backbone chain. Based on backbone chain, that polymers are classified as organic polymers and inorganic polymers. Inorganic polymers, backbone chain is made up from carbon. Chain is made up from carbon. Carbon is organic material, therefore that polymers are known as organic polymers. Example, synthetic polymers. Then inorganic polymers, that backbone chains are made up from material other than carbon, that are made up from atoms other than carbon. For example, glass and silicon rubber, that are nothing but inorganic polymers. Then classification based on thermal responses, how that polymer material give response to heat action. Based on that, polymers classified into two types: thermoplastic polymers and thermosetting polymers. That how that heat response is different for these two type of polymers. Based on heat response, polymers are classified into two types: thermoplastic and thermosetting. Thermoplastic, these polymers soften on heating and can be converted into any another shape, and that shape they can retain on cooling. That is, when they are hot, then that can be molded. Molding is possible. They can be molded in any shape, and that shape which was there in a hot condition, They maintain that shape in cooling form after cooling. For example, cellulose nitride, then polyacetylene, polyethylene, PVC, that is polyvinyl resins, PVC also, that type, uh, thermoplastic. Then thermosetting, second type is thermosetting. They do not soften on heating. Then they undergo irreversible chemical changes on heating and get converted into unfusible mass. As after heating, that polymers do not soften, they form infusible mass, they convert into the infusible mass. Therefore, that are irreversible polymers, they cannot be reused. Reuse is not possible for thermosetting. Example, epoxy plastics, bakelite, etc. That is old black colored holders, and that holders and that sockets, light sockets, old sockets. Now material is different, but old that black colored material is nothing but bakelite. That is thermosetting polymer. Difference between thermoplastic and thermosetting, there are some points for differentiate that two types. That is thermoplastic, that are formed from addition reaction, and thermosetting formed from condensation reaction. This is main difference, remember. Formed by addition reaction, formed by condensation reaction. Thermosetting formed from condensation reaction, thermoplastic formed by addition reaction. Then thermoplastic, that are generally long chain linear polymers, and these thermosetting, that are three dimensional cross linked network structure, cross linked network structure, or branched chain polymers. These are linear polymers, thermoplastic linear polymers, thermosetting branched chain polymers, or ठीक है, branched chain polymers. Then thermoplastic soften on heating, and since that are formed, that there are secondary forces between that linear chains that broken easily on heating. Therefore, that material soften on heating since chain are linear, but do not soften on heating since strong covalent network structure is there. Therefore, that are not broken. Reshaped and reused, the thermoplastic reshaped and reused. These are thermosetting, cannot be reshaped and cannot be reused. Then thermoplastic generally weak, soft and less brittle, and here these are hard. Thermosetting hard, heavy, strong, and more brittle. Then thermoplastic reclaimed from waste, here cannot be, thermosetting cannot be reclaimed from waste. Then last one is dissolve in strong organic solvents, thermoplastic dissolve in strong organic solvent, while these thermosettings insoluble in most of the solvents. Okay, this is about classification of polymers. Then next type is next type for last method for classification is classification based on physical properties of polymer material. Based on that, polymers classified as, first type is elastomers. They have long range elasticity, therefore elastomers. This is, and range elasticity and undergo high elongations even on application of low stress, that are rather weak mechanical strength. Example: natural rubber, synthetic rubber, silicon rubber. These are examples of elastomers. Then plastics, more stronger than elastomers or rubber. Plastic is more stronger than elastomers. They are hard, rigid, stiff, dimensionally stable, soft and flexible, that are plastic. Then third type is fibers. These are stronger polymers and having length at least 100 times than its diameter. These are strongest polymers having length at least 100 times than its diameter, that are known as fibers. For example, wool, cotton, that are natural fibers, and synthetic fiber, acrylic fiber, polyesters fibers, as like that. Then last type is liquid resins. That is polymers used as adhesives, sealants, etc., that are which are in a liquid form, therefore that are known as liquid resins. We already know that liquid resins, many are used, available in market, also used as adhesives, Feviquick, Fevicol, as like that. That are example epoxy adhesives and polysulfide sealants and epoxy adhesives, that are liquid resins. These are different methods for classification of polymers. Then in the next lecture we discuss molecular weight of polymer materials, molecular weight of polymer materials. Thank you.